welcome you all to Think Max. We are in class 11 Max, chapter 6, Permutations and Combinations. In this session, we are going to discuss about the exercise 6.1. In exercise 6.1, you have 6 questions. All 6 questions will be discussed in this session. So it is a very simple exercise based on the fundamental principle of counting. Okay. So let us get into the problems. First one. How many three-digit numbers can be formed from the digits 1, 2, 3, 4 and 5, assuming that there are two parts. Repetition of the digits is allowed. Repetition of the digits is not allowed. Okay. So here what is the condition? We have to form three-digit number using the digits 1, 2, 3, 4, 5. Okay, so what are the digits we have to use? It is 1, 2, 3, 4 and 5. So how many numbers are there? 1, 2, 3, 4, 5. So in 1, 2, 3, 4, 5 we have 5 numbers. Okay, so we have to use this 5 numbers and form 3-digit number. The condition is, first condition, repetition is allowed. That is, we can write the same number in the hundreds place also, tens place also, ones place also. Okay. Now let us find out how we can fill it up. So for the first part, what is that? With repetition. The first part is with repetition. Repetition means if you fill one here, this one can also be filled here. This one can also be filled here. For a three-digit number, we have hundredth place, tens place and ones place. So all three places can be filled with the same type of numbers. So in hundredth place, you have 5 options. You can fill either 1, 2, 3, or 4 or 5. So you have 5 options here. In the tens place, also you have 5 options because there is repetition. You can repeat the number which is placed in the hundredth place. In ones place also you have 5 options because you can repeat the number which is placed in hundredth place or which is placed in tenth place. So all 3 places will have all 5 options. So, by fundamental principle of counting, number of three-digit numbers with repetition is 5 into 5 into 5. So, 5 5s are 25. 25 into 5 is 125. This is the answer. Okay, clear? Very simple, isn't it? Next, for the second part. For the second part, what is the condition? The repetition of the digits is not allowed. That is, we have to fill without repetition. For the second part, it is without repetition. That means if you take the hundredth place, tenth place and ones place, suppose if I fill the hundredth place with any one of the numbers from 1, 2, 3, 4, 5. So we have 5 options. So I have 5 options for the hundredth place. I can fill any type of numbers here. As it is without repetition, I should not fill the number that is filled in 100. So one number gets reduced. So it is, I have only 4 options. Now what about the ones place? It is without repetition. So I should not fill the number that is filled in 100th place and 10th place. So 2 options go out. So 5 minus 2, it is 3. Okay. So I have 5 options for 100th place, 4 options for 10th place and 3 options for ones place. Therefore, by fundamental principle of counting, number of three-digit numbers without repetition is 5 into 4 into 3. So 5 4s are 20, 23s are 60. This is the answer. Very simple, isn't it? So all these problems will be very simple. So let us move on to the second problem. How many three-digit even number can be formed from the digits 1, 2, 3, 4, 5, 6, if the digits can be repeated. Okay, so we have to note 3-digit even number. And what are the digits we have to use? 1, 2, 3, 4, 5, 6. And the condition is it can be repeated. Okay, so in how many numbers? 1, 2, 3, 4, 5, 6. What we have totally? 6 numbers are there. In 1, 2, 3, 4, 5, 6, there are 6 numbers. We need even number. So even number means, what are all even numbers here? 2, 4, 6. So 2, 4, 6. There are 3 numbers. There are 3 even numbers. So we need 3-digit even number. So it is the 100th place, 10th place and 1's place. Okay. If we need a even number, this 1's place should be filled with even number. What are the even numbers we have? 2, 4, 6. You can either fill 2, either fill 4 or 6. So how many numbers are there? 3 numbers. We have 3 options. So in 3 ways you can fill the 1's place. You cannot fill 1 or 3 or fill because we need even number. So 1's place must be filled either with 2 or 4 or 6. This is the condition for even number. What about 100th place and 10th place? What is the condition? Digits can be repeated. Here we no need to fill only the even number. Also in 10th place, no need to fill only the even number. So we have all 6 options for 100th place. As digits can be repeated, you can use any number. You can use even 246 or 135. So all 6 options are there. So it is 6 into 6 into 3. So therefore, let me write, by fundamental principle of counting, number of 3-digit even numbers is 6 into 6 into 3. So 6 6 are 36. 36 into 3. 6 3s are 18. 3 3s are 9. 108 ways. So there are 108 ways of writing a 3-digit even number using 1, 2, 3, 4, 5, 6. Clear, children? Okay. So moving on to the third problem. How many 4-letter code can be formed using the first 10 letters of the English alphabet if no letter can be repeated? So it is a 4-letter code. So note the point. So it is a 4-letter code and first 10 letters of the English alphabet. Who are they? A, B, C, D, E, F, G, H, I, J. So these are the first 10 letters of the English alphabet and no letter should be repeated. Okay, this is the condition. So here you have number of letters is 10. It is given. First 10 letters means number of letters is 10. So it should not be repeated. So for the first 4 code, okay, I am naming this box as 1, 2, 3, 4. For the first box, you have the option of 10 letters. You can fill any 10 letters from this. Okay. What about in the second box? We should not fill the letter that is filled in the first box. So it is 10 minus 1, which is 9. No repetition here. That's why it is 10 minus 1. It is 9. What about the third box? Here we should not fill the letter which is filled in 1 and 2. So 2 options go out. So it is 10 minus 2, 8. Next, in the same way for the fourth box, we should not fill the letter that is filled in 1, 2, 3 boxes. So 10 minus 3 equal to 7. So here you have 10 options. Here your second box you have 9 options. Third box you have 8 options. And for the fourth box you have 7 options. So therefore, by the fundamental principle of counting, Number of 4-letter code using first 10 letters of the English alphabet is 10 into 9 into 8 into 7. So what is 10 into 9? 90. 90 into 8 into 7. What is 90 into 8? So put a 0. 9 8s are 72 into 7. So 0 sevens are 0, 2 sevens are 14, 7 sevens are 49 plus 1 it is 50. So you have 5040 ways of writing a 4-letter code using the first 10 letters A, B, C, D, E, F, G, H, I, J. Clear, children? So moving on to the next problem. Fourth one. How many 5-digit telephone numbers can be constructed using the digits 0 to 9 if each number starts with 67 and no digit appears more than once? Okay. So here what are the conditions? It's a 5-digit telephone number. Okay. So you have 5 digits. Ones, tens, hundred, thousand and 10,000. Okay. These are the 5 digits. Next, what is the condition? We have to use the digits 0 to 9. So let me start writing. So we have to use the digits 0 to 9. So what are the digits in 0 to 9? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So in this, how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have totally 10 numbers in it. Okay. Then what is the condition? The number should start with 67. That means in 10,000th place, it should be 6. In 1,000th place, it should be 7. This is fixed. Okay. So we cannot change this. So this is fixed. Okay. 6 and 7 fixed in 10,000 and 1,000 place. Okay. This is fixed. So, two numbers are fixed. And here what is the condition? No digit appears more than once. That means there is no repetition. So, we should not write 6 and 7 in any of 100th place, 10th place or 1's place. So, 2 number gets reduced. So, 10 minus 2 is 8. So, when you go to 100th place, you have only 8 options. Okay. Okay, it is not number 8. So here 6 and 7 fixed. So in 100th place, you can use any of the 8 numbers except 6 and 7. Okay. In the 10th place, you have to use any of the numbers except 6 and 7, and the number that is used in 100 should not be used. So again 1 will be reduced. So here 8 options, here 7 options. Again in one's place, we should not use these 2 numbers and number filled in the 100th place, number filled in the 10th place. So 4 options get reduced, so it will be 6. Okay. Now let us have this. So in 6th and 7th, this is fixed. So we have only one option for the 10,000th place and one option for the 1,000th place. In other things, in the third place, you have 8 ways. In the fourth place, you have 7 ways. In the fifth place, you have 6 ways. So, let me write the solution. By fundamental principle of counting, number of 5-digit telephone number without repetition. So, in the 10,000 place, it is fixed. We have only one option. In the 1,000th place also, we have only one option. In the 100th place, we have 8. In the 10th place, you have 7. In the 1st place, you have 6. So, 1 into 1 is 1. 1 into 8 is 8. 8 sevens are 56. So 56 into 6. 6 6 are 36. 5 6 are 30 plus 3 it is 33. So you have 336 ways of filling a 5-digit telephone number that starts with 67. Clear, children? Okay. So moving on to the fifth problem. A coin is tossed 3 times and the outcomes are recorded. How many possible outcomes are there? We all have seen the coin. So a coin has two sides, head and a tail. Okay. So a coin has two sides, head and tail. Now what is the activity? A coin is tossed 3 times. So and the outcomes are recorded. How many possible outcomes are there? So while tossing a coin, the coin will fall down either as head or as tail. Okay. So this is the activity happening. Whenever you toss a coin, it will fall down as head or it will fall down as tail. Okay. So this is done 3 times. Okay. So a coin is tossed 3 times. So whenever you toss a coin, you have the option of either head or tail. Even if you toss the coin for the second time, you have the option of head and tail. Even if you toss for the third time, you have the option of head and tail. So in each tossing, you have two options. Therefore, by the fundamental principle of counting, number of possible outcome is 2 into 2 into 2, which is 8. Okay, clear, children? Very nice. Yes. Last problem, sixth one. Given 5 flags of different colors. How many different signals can be generated if each signal requires the use of two flags, one below the other? So, what are the things given? 5 flags of different color. So, you have 5 flags of different color. Any color. I have chosen some colors. They have given 5 flags of different colors. What is the question? How many different signals can be generated if each signal requires the use of two flags? We have to use two flags, one below the other. Okay, like this, one below the other. So it is a different flag. So you can use any, how many colors are there? 5 colors are there. So any 5 color can be used here. Okay. For the first flag on top, you can use any 5 color. But it is of different signal. So what you have to do? You have to use a different color in the bottom part. So the color that is used in the top part should not be used in the bottom part. So one color gets reduced. So it is 4. So this type of flags will be in this way. So on top one color, bottom one color. So you have these type of option. This is one example. Okay. So you have more type of flags like this. Let us find out how many types of flags we get using this fundamental principle of counting. So the required number of signals are, so what is that? It is 5 into 4. You have 5 options for the top part and 4 options for the bottom part. So the answer is 5 into 4, which is 20 ways. In 20 ways. This is some example. I have shown just 5 flags. The flags will be looking like this. So like this, you have 20 different type of signals. Okay, clear? Very easy. Like, is it so? Yes. So with this exercise 6.1 is completed. If you like my videos, just share among your friends. Okay. And also subscribe to ThinkMax so that you will get the notification as soon as I post my video. Thank you.